Okay, third and final video for the Unit 11 review. For questions 1 through 6 on the review, see video 1. For 7 through 13, see video 2. And now 14 through 16 we'll have in this third video. So problem 14, Unit 11 review, says sketch this. So we have an exponential decay because the base is between 0 and 1. So we're going to follow our same process we always use. What's happening to x, what's happening to y. So x, none, no changes. Y is opposite sign. We'll switch the sign. That's what I mean when I write opposite, because of this negative. And then this plus 1 moves it up 1. So not a lot of changes there. So our original table, because this is exponential decay, we use the points -1 comma reciprocal of the base. The base is 1/4. So the reciprocal, flip it over, it becomes 4/1, or just 4. So that's our base. Reciprocal of our base is 4. So -1 comma 4 and 0 comma 1. Those are the points that we use, the original points we always use for exponential decay. So then the new points, well, x will not change. We identified that here. And the y's need to be opposite and then up 1. So opposite of +4 is -4, then up 1 from there is at -3. Here, opposite of +1 is -1, up 1 is 0. And then y equals, the original, by the way, was right. Y equals 0 for the horizontal asymptote. And horizontal asymptote now will move vertically, so it moves up 1. So it's at y equals 1. So let's get a coordinate plane going here and sketch this thing. So y equals 1, horizontal asymptote coming across here like this, y equals 1, and 0, 0, -1, -3, so that forces the shape to look like this. It's the only way it can approach that asymptote and go through those points. So we had 0, 0, and we had -1 and -3 right there. Alright, so that's it for this one. Let's go into 15. Alright, problem 15, we're asked to write the function that produces this graph. This is an exponential decay graph. You could also write it as exponential growth if you write the reflection correctly. And by the way, if you're having trouble with anything specific on this review, make sure you go back to the videos for that specific topic where you can get a lot more example problems to look at. So all of those videos are in the same Unit 11 playlist. So write the function that produces this graph. Okay, we can write it either way. We can write it with decay or with growth, and I'm actually going to do it both ways. So first we'll do with exponential growth here. So we track this first perfect point to determine the horizontal and vertical movement. So how much did it move left and right and up and down? This point should normally be at 0, 1 right here. That's our first step in our process. So it's down 1, 2, 3 and right 1. So for growth, down 3, right 1. That's going to be the same for growth or decay. Down 3, right 1, and then the next perfect point gives us the vertical distance from that point to our horizontal asymptote, gives us the base. So it's 2 away, so the base will equal 2. Okay, so let's go ahead and over here and we'll do decay, and it's still down 3 and right 1, and the base would just be the reciprocal of this. That's the only difference. Base is 1/2. Alright, so now let's make we've identified how it needs to change, so now let's make our function from that. So with growth, by the way, this is down 3, right 1. For growth, we also have to reflect. Let's write that, reflect, because it should be growth is normally shaped like this, so it's reflect over y. So if we choose to use growth, we also have to reflect it like that. So with growth, the function would be f of x equals, the base is 2, and I'm going to put that negative there to reflect it over the y, make the x's opposite, x raised to the power of x, and we want to move it to the right 1, so that's a subtract 1 there. And then we want to move it down 3, so that's a subtract 3 right there. Okay, so that's how it would be if you chose to write it using exponential growth. Now if we use decay, it's very similar, except we'll use a base of 1/2, and we don't have to worry about reflecting it over the y because that part's already handled. So that would be f of x equals base 1/2 raised to the power of, move it to the right one, so that's an x minus 1 here, and down 3, subtract 3 out here. So either way, I will accept. Alright, so that's it for number 15. Alright, now for problem 16, the final problem on the review, we're asked to sketch this graph, and we have a base of e, so it's an exponential growth. So let's use our process. So we'll identify what is happening to x, what is happening to y, make our original and new tables, and then make the sketch. So what's happening to x? It is moving to the left 2 because of that plus 2 there, so left 2. The y's are opposite because of that negative there, so we have to make the new y's opposite from the old ones. And that subtract 5 there moves the graph down 5, moves all points down 5. So the original table would be 0, 1, and 1, base always, and the base is e, and e is approximately 2.718. So refer back to that lesson if you need to, but e is approximately 2.718, that value. So that's what we're using here. Now the new table. So x's go left 2, so it was at 0, now negative 2. This x was at 1, left 2 takes you to negative 1. Now for the y's, so make it opposite. It was 1, opposite makes it negative 1, down 5 takes you to negative 6. So again, it's positive 1, make it opposite, negative 1, down 5 from there takes you to negative 6. Okay, next one, we're at 2.718, make it opposite, negative 2.718. And then down 5 takes you to negative 7.718. If you need to write all that out, that's fine. Sometimes that makes it easier. Basically, you're doing this. You've got 2.718. You make it negative because it's opposite, and then you subtract 5 from that. So that gives you the negative 7.718 for that other y coordinate. Okay, our original horizontal asymptote, y equals 0. New horizontal asymptote, down 5, so y equals negative 5. So now we have enough to make that sketch. So we'll put the coordinate plane in here. The horizontal asymptote is at y equals negative 5 across here. It's negative 5. And we have points at negative 2, negative 6 right here. And negative 1, negative 7.718. So based on that, the graph has to be shaped like this. And then we'll label those points. Negative 2, negative 6 was the top point, and this one down here was negative 1, negative 7.718. So that answers number 16. That's it for this video and it for the Unit 11 review.